Today, we are going to secure the node of our AKS cluster. In previous couple of videos, we talked about overview, of course, the components, then securing ASR, then securing cluster master. In today's video, we are going to learn how to secure the nodes for our AKS cluster. And in upcoming video, we'll be talking about securing the pod, network, and of course, applications. And then we'll create the entire architecture and talk about the best practices. So let's get started. Let me share my screen and take you through with the diagram, right? Okay. I hope you can see my screen now. Yeah. So let's get started. This part is done, this part is done, this part is done. This is where we are talking about in today's video. In pod, I think I should also mention something so that we should not forget, which is because what is running in the AKS, it's the application or the microservices. It doesn't matter, but we need to talk about securing our application inside the AKS cluster as well. For now, we are only talking about securing the AKS cluster. And once we are done with all the components, we'll talk about how to secure the application separately. And then we'll go through the entire architecture, or maybe one or two architecture, microservice architecture on AKS. And let's see, that comes later. Let's focus on the node right now. Node, this one, this part. Come on, this node. Yeah. So we covered the AKS cluster now. And whenever we create nodes or whenever we create the AKS cluster, we get the nodes to work upon. It could be auto-scalable or manually scalable under the VMSs. Okay. You can choose that for sure. And the very first thing, just like any other security practices, first is the access. And by default, we do not have any public IP address on this node, so that's a good thing. However, SSH is enabled by default and only accessible using the internal IP addresses. So you must be wondering, what about the security? Why I'm mentioning this? Why I'm mentioning this? Because by default, the SSH port on the node is open to all pods running in the cluster as well. And preventing direct SSH access from the pod network to the nodes helps limit the potential blast radius of damage if container in a pod becomes compromised, right? So what we learned, two things. First, there is no public IP. That's a good thing by default. Second, SSH is enabled and we should not allow or we should prevent direct SSH access from the pod. SSH access from pod to the node to minimize the blast radius. Yeah. Cool. Two things covered. This is for the access. Now we have already covered many times, which is Azure or Cube RBAC, which has already been taken care in the previous video. You can control the permission as least privileged principle and allow access accordingly using the RBAC. So that's how we can manage the access for the nodes as well. And of course, I was talking about network, but that's a network traffic, not the access as an access. So that comes later. Let's come to the another next step, which is what all we got on the node. We got the disks, right? We got the data that we are storing there. So the data stored on managed disks is automatically encrypted at rest within the Azure platform. So these nodes can have, or you can add the disks. manage disks on these nodes, and for the data, of course, data, and which is encrypted by default, or you can manage the keys by yourself. That's a secondary thing, but that's how this is secure, or you can make it more secure by adding your own keys through Key Vault, right? Now, the third thing is, we talked about the user access. Now it's the network access. We can easily control the network access or filter the traffic through NSGs. NSGs are applicable on the nodes. These nodes are running on your virtual network. Yeah. So NSGs will help you control the network traffic. Now, the access is done, the data is done, the network is done. Another thing is vulnerabilities. What kind of? For which the patches are released. Now, there's two things. We got Linux node and we got Windows node, and both has a different way of controlling or handling the patches. Yeah? For Linux, each evening, Linux node in AKS gets security patches through their distro security update channel, and this behavior is automatically configured as the nodes are deployed in AKS cluster. And to minimize the disruption and potential impact to running workloads, nodes are not, I'll say it again, not automatically rebooted if a security patch updated, right? So Linux is automatic patch update, but no reboot. But the same thing doesn't happen with the Windows. No patching. What you need to do, you need to play smart, or that's the only way that we got here, which is more like you need to upgrade it. So for Windows update doesn't automatically run, as I said, and apply doesn't apply the updates. So in each, it is more like on every second Tuesday is of the month is the patch cycle. So what is recommended? Use you need to upgrade your nodes so that they would run on the latest image once the patch cycle is over or near the patch cycle, right? So as soon as the new patches are released, what you need to do, you need to upgrade your nodes so that they start running on the latest image, because all the image in the marketplace are patched, right? They are coming with the latest patches. So that's how you need to deal with the Windows nodes. Upgrade with latest image. Yeah, that's how you're going to manage your Windows. All right. Well, these are the things by which we can secure our nodes, and you must be wondering, and I wouldn't deny there could be another stuff, but as I planned so that it will make more sense to us component wise, that's why I'm not touching the network policies and Azure policies and secrets and other stuff. So let's go step by step so that it will make more sense and we should not forget anything. And if you think there is something that I missed, please comment in the comment section and we'll highlight it in the description or in the next video. So let's meet in another video where we'll try to secure pods. Till then.